in the demo, I would appreciate if you're around and you have access, I would appreciate if you go to your web browser and type repositive.io. I'll give you a little bit of time. You're going to find something like this. If you want to actually use it, you click Create Account. You don't actually have to do anything. If you click on Create Account, it doesn't appear for me, but actually, there is either you can log in with your Google credentials or with your LinkedIn. So just if you click on Google or on your LinkedIn and you have the session already open, it's as simple as that. And this is what you get. So currently we have almost 1.2 million human genomics data sets. We have 47 sources, data sources. We know we have around 300 that we have identified already. They are not in production yet, but we will be adding them. The good thing about Repositive is that not only it doesn't just work for the providers, it also works for the users. So maybe a user would like to make her data sets findable. It's actually possible to register your own data, or is it also possible to request data? And just to make it even more interesting, I'm going to ask someone to tell me what kind of data research they're interested in. What's your field? Yeah. Sorry? Epilepsy. This is all live, okay? No, I don't know her. This is the first time I've met her. Sorry, what's your name? Yuka. Hi, Yuka. So I've never met her, and now I'm gonna show you live what happens when I type epilepsy. Is this epilepsy? Is that properly spelled? And I'm just gonna click enter. So currently there are 1,846 epilepsy datasets indexed by Repositive. On the left-hand side, you see 3 types of filters. There are 2 types of ways in which this data is provided. One of them is restricted. This is what we meant, that it's not directly downloadable. So you have to actually apply for permission, so to speak. But then there are also open access human genome datasets, meaning that just by clicking on them, in principle, you should be able to get those data. There are other types of filters. In this case, we have assay filter. So we have the maximum type of assay that matches the epilepsy search term. We have 1,794 whole exome sequencing, whole exome sequences. We have 49 RNA-seq, 45 whole genome sequencing, and so on. And then we also can search by data source. So you can actually, let's say, for example, that we are interested in open that are, I don't know, RNA-seq, and that are in SRA. Okay, so now, as you can see here at the top, we've performed that series of filters that basically are matching the metadata, that is the description that the scientists that deposited those data sets have used And this is the open data, so the public data that is accessible through the repositories where these data sets are held. So now I have perhaps enough amount of data so I can begin to actually interact with those data sets. So I'm now going to actually make it appear in one page. You can see that we have these dataset cards. You can see where they are open, how many times they have seen, where they have any comments regarding to, specific people that say, oh, I don't like this, or this is good or bad. In a way, a little bit like TripAdvisor, that you have the reviews of people that tells you, this is a good thing, this is a bad hotel, and so on. So I'm just going to click on this first one. And as you can see, the metadata is pretty much, so the data that has been used is to describe this data set is not very complete. But because I am a good guy and I like, to add things that are, I like to contribute, and I don't know, I'm just going to put a comment. Or perhaps I could, is Homo sapiens. Okay, so I'm just going to add a new tag, Homo sapiens. And I do that. And when I look at my profile, I actually get points. And if you get lots of points, you get presents. And in fact, the more you add, the higher the score you get, and you can be one of the most contributing guys in repository, and you might be invited to come and talk at our annual user meeting to tell us all your experiences. So you can actually follow the data set. So anytime that someone writes something, let's say this is a test. I hope I remember to delete this. Then I should get it at some point, an email that looks something like this. Where is it? You get notified about things that happen to that event. You get this one. Right. Hey, a dataset you are following has a new comment. So, as you can see, we are trying to build a community around datasets. We are trying to have a global representation of the data for specific conditions, for specific types of classifications. And it's all around the social networking aspect of how people interact, how people search, how people actually select specific data sets. Okay, so I'm going to go back to the presentation. Should we have a little break? Let's have a little break.
Who deposited this data set?
Sorry?
Was it you to deposit this data set? Or?
So we have a team of people who develop what we call scrapers. So scripts, first we identify what repositories are out there through the internet. We are constantly looking. We are scientists who know about the human genome research, and so we're also close to Hinkston, and so we keep an eye on the different data sets and the different data sources that are out there. Once we have identified, we take all the public data, even restricted access data. The metadata is public because the description is not sensitive to the patient. You can know about the samples and so on. And then we take all that data, we ingest it, structure it, and put it under one single interface.
So what does it mean, add the samples? I saw there was an option, add samples.
Here. So this means that if you happen to be one of the people who develop or who worked with this data set, or you happen to see that actually there is some free text there that says something about the samples, you can actually add, yeah. So in a way, what we are doing, the same that Wikipedia is doing, we are crowdsourcing the annotation of the metadata, allowing people to actually add those annotations and get recognition for that, because that's very important.
What about special maybe rights for the owners of this data set? Are they capable of changing something?
Anyone, as long as you are registered, you can change anything. Like Wikipedia. And yeah.
If somebody comes in and writes a derogatory comment about the data set and say, this data set has very limited metadata available,
Yeah.
it is practically useless. Do you monitor comments like that? Or do you see what I'm saying? Or do you allow those comments to be made?
We do, yeah. Currently, we know what's being done. Whether, and the volume of currently is sufficient for us to allow to actually monitor all these things. Whether, what will happen maybe when we have 20,000 users or something like that, that'll be different. So let's have a little break. If you still think that you find this useful, I will welcome to come back. We have a special prize for those of you who stay in the end. I still need to think about what it's going to be, but let's have 5-10 minutes. Let's say 10 minutes, 15 past 8. Back. So you can have some more wine if you like. Yes, please. Okay, so thanks very much for still hardcore participants. So what's the prize going to be for those of you who have come back and stayed until the end? What should the prize be? Okay, let's do this a little bit more interactive. Okay, so I would like to ask you, what's your research about? What kind of data are you interested in? Yeah. Skeletal diseases. According to this, finds 34,000 results. And again, it says not available the assay. That doesn't mean that it doesn't have an assay. It means that the scraper, when you get from the repository, wasn't able to find a description. But currently, all of these seem to be open. So I'm just going to, here are the data sources. What would be the type of, just by looking at the data sources, methyl cancer, so this, it seems like most of them are related to cancer and methylation. Would you be interested more in like human genomes? Okay, let's click on SRA. And there you have mostly RNA-seq. Is this something of your interest? RNA-seq? Or more like genomes? Okay. Sorry? Maybe we could use something else. Maybe we could use bone, maybe? Bone? That might give us something else. Whole exome sequencing, whole genome sequencing, which one you prefer? Exome or whole genome? Okay, there we go. They come from SRA. Bone marrow cell. I don't think that is what you wanted, is it? So I'm not going to lie to you. The search is not perfect, and it's not perfect because currently the search that you get is by matching terms. And we are working on that. In fact, what we would like to do in the near future is to actually combine knowledge from publications that provide the context, so that if you search for heart, then you know that, or the search machine knows that actually cardiac data sets are related to heart, right? So this is something that we are working on, and we are very much aware of. But perhaps from some of this data, you might find things that are interesting. I think that the good thing about this is that there is a bit of open access data, and the fact that you already have access to open access, it means that you don't have to. You can already begin to work with those data sets. Anyone else would like to ask for a particular type? Yeah. Gene specific. What we find is that gene descriptions tend not to occur in the study description for the metadata. So most likely the gene information will be behind the firewall. But anyway, is there any particular gene that you would be interested? We can try and see. How do you spell it? BRCA1. Well, actually, we have collections, and we have 11 collections. One of them is breast cancer collection. So we have 11,000 data sets. If you click on the filters here, you can see, so we have, would you be interested in exomes or whole genomes? What? Exomes, okay, so let's click on there. Restricted or open? Open. Okay, so let's see, we find this data cards. It says exome sequencing of tamoxifen resistant and sensitive breast cancer cell lines. So the next thing that you would do, you click on access data, and that points you to the actual source from which this data set was found from. And then you click there on the run. And then you need to install the SRA toolkit, but it's just simply follow a set of instructions. Your bioinformatician should be able to do it easily. Even I was able to do it. So if you follow the instructions, you have to install something on your computer, and then through the command line, you basically download the data. So as you can see, yeah?
To me, it's even something new, but there's a tool called Aspera Connect.
Aspera, yeah.
And then when I tried that, it was much faster than the SRA toolkit. And you don't need to do command line, so that was what I was going to
Yeah.
recommend to folks.
So basically, what we are providing here, first and foremost, is a global overview of what data is out there for any given condition, for any given search term. And then we link to where the data is. Now, obviously, you can get the data anyway, and even if you just search SRA, you will be able to find that data. What you find here is one place where you can see and hopefully, you know, restrict and filter according to your I guess, specification. So I've mentioned that we had a number of collections. We also have specific projects that are accessible, like the 1,000 Genome projects. You can also see the different data sources that are available there. So one of the things that I did, and I'm coming back to my presentation, I did this a while ago, but I'm someone who has been very keen on personal genomics. So understanding your own personal genome. And you probably might have heard of 23andMe, which is this direct-to-consumer provider that basically for $100 and you know, and an email account, then in 6 weeks they provide your health report. They run a chip array, SNP chip array, and basically you get approximately 1 million SNP from your genome. And so I decided to go to Repositive and search every single SNP, sorry, 23andMe. So I just search by 23andMe, which is not a condition, it's a data format. So every data card that matches 23andMe is retrieved. And I got a total of 3,100 23andMe genotypes. So you can see the sources where they came from, mostly OpenSNP. And we went through the curation process. That's one of the things that you're going to find. And this is something that I can tell you from my own little experience, that you're going to have the same genome used for one study in epilepsy, one study in, you know, cardiac arrest. There's a huge amount of duplication. So having access to the data doesn't mean that you can actually reuse that data. The curation aspect, and this is what took most of our effort. So just getting rid of those files that weren't corrupted, those files that, you know, instead of being 23andMe genotypes, they were, you know, PDFs. And you see a lot of problems like that, you know, getting actual data that is usable is going to reduce your actual number of results. So we curated all of those data sets that actually were mapped to the reference genome GRCH37 and that were not duplicated, basically. And we ended up with a curated set of 2,402 genotypes. And so this is a breakdown of the 1,000 Genomes project that you can get from any research, so basically from their website. And we performed a principal component analysis where in blue, so these are the 2,400 individuals that I downloaded from 23andMe, and I'm overlapping the African, Asian, and European individuals from the 1,000 Genomes project. And you can see that they basically map very well they're very well separated. And cool, so I have 2,400 open access 23andMe genotypes that I can do whatever I want with that. Obviously, that means not that I'm going to look for identity or whatever, but that the fact that I can now do specific research questions on this reference data set. But something that was interesting, and in 2016, I think it was November, there was this article in Nature that mentions the persistent bias in terms of the ancestry of the GWAS datasets that have been so far published to date. And as of 2009, 96% of all GWAS studies were of European ancestry. And in 2016, it went a little bit better, but we still find that according to this, and this is just looking at the catalog of GWAS studies that is actually maintained by the EBI, by the European Bioinformatics Institute, it showed that 81% of all of the GWAS studies in August 2016 were of European ancestry. So how does this compare to my 23andMe? That was my question. So how does that compare? And that's what we found. Actually, around 95% really are European. And around 2% Asian and 2% African. So, of course, you cannot make any assumptions about this, but is this actually a clear reflection of who's actually benefiting from direct-to-consumer genomics? Is it then that the only people who currently have the capability to analyze their personal genomes are white, rich people? It gives food for thought. I cannot make any inferences, but this perhaps could be a proxy of the fact that the personal genomics direct-to-consumer testing field is slightly behind the already incredibly biased GWAS studies. And with that, I am going to finalize. I'd love if you guys come to our booth. We are in booth 732. We are friendly. We have T-shirts, and hopefully we can even help you get closer to your research, and we can share data eureka moments together. So thanks very much. I'll be happy to answer any questions.